Under that chapter, we have discussed about the chemical nature of enzymes and their structure and the characteristic features of enzymes. Today, we are going to discuss about how the enzymes enhances the rate of reaction. Yesterday, we had discussed about the characteristic features of enzymes. In that, one point was discussed. What is that? That enzymes helps in increasing the rate of a reaction. How it will? That means how the enzymes will enhance the rate of reaction. See, with in previous slides, yes, in this slide, we have observed that without the participation of enzymes, how the reaction rate is. That means with the minimum rate of reaction is observed without the enzyme participation. And also the same reaction with the influence of enzyme, how it will be. That is also observed under the influence of this enzyme. Rate of reaction that increases enormously or a high rate of increase is observed in the rate of reaction by the participation of enzymes. Then how it will happen? That means by the presence of these enzymes, how the enzyme reaction rate increases. What is the reason behind that? So here one of these characteristic feature of enzymes is this enzymes that enhances the speed of biochemical reactions by lowering the activation energy. That was discussed yesterday's class. So here the enzymes, how they enhances the rate of reaction. See, this is explained very clearly by taking one example that is that explains how the rate of reaction will be enhanced by the participation of enzymes. For that, usually for starting a reaction, substrate molecules should have minimum activation energy. Substrate molecules should have minimum activation energy. Then only a reaction will be started. That means substrate molecules, this substrate in any reaction, substrate molecules, they starts the reaction. For starting of this reaction, this substrate molecule should have minimum activation energy. That may be 1 or 2 or 3 or more than that also. For example, what is the use of this activation energy? This activation energy helps in moving the molecules closer to one another and for bonding, creating bond between that molecules. This activation energy, which is possessed by the substrate molecules, are definitely required. So here, rate of reaction is enhanced by the enzymes. In what way the enzymes helps in enhancing the reaction is explained by taking this example. So here, substrate molecules with activation energy starts the reaction. Why this activation energy is needed? Means this activation energy is helpful in moving the or in movement of the molecules, as well as in bonding the molecules with one another. So this activation energy is used. Then observe these diagrams. All these are the molecules with the different activation energy. So here one molecule is having 4 activation energy, and some of them are having 6 molecules of sorry 6 activation energy, and here 5 activation energy. So here the molecules with the different activation energy are there, which are ready to participate in the reaction. So for example, this reaction requires 5 number of activation energy. 5 calories of activation energy is required for this reaction to start and give the end products. And here molecules with the different activation energies are there. Out of this, only the molecules which have 5 calories of energy will participate in this reaction. So if we calculate the number of molecules in this, how many molecules are there? Only one molecule is there, which is having 5 calories of energy, activation energy. So this only one molecule takes part in this reaction, and that turns into end products. So limited number of molecules are participating in this reaction, in which enzyme participation is not there. Only molecules with their higher energy, they are participating in this reaction, and they are giving the end products. So this is a normal reaction without the participation of enzymes. Then next, what happens if the enzyme takes part in this same reaction? Let us observe the change. Here, in the same reaction, it is forwarded with the support of enzyme, and this enzyme influences the reaction. Now, if the enzyme is added, to this reaction, this enzyme, in what way it helps in enhancing the reaction? Now we'll discuss about that. This enzyme, as we know that this enzyme, structurally it consists of active sites, and that active sites helps in our previous slides we discussed about that. So that enzyme, by having active sites, it invites the substrate molecules irrespective of their activation energies. That means all the molecules which are having less activation energy will come and takes the position on the enzymes, and molecules with higher energy also, they comes and attaches with the enzyme. That means all the molecules without the issue of their activation energy, they comes and takes a place on the enzymes. By that, what happens? Majority of the substrate molecules are participating in the reaction by the presence of this enzyme. That is a one fetching point. In absence of enzyme, only the molecules which are having higher energy, they takes part in the reaction in giving the end products. But by the presence of enzyme, this molecules, majority of the substrate molecules, that means the molecules which are having less energy, less activation energy, they too participates in the reaction, and the molecules having higher energy also participates in the reaction by taking the position on the enzymes at the active sites. So in this way, that enzyme, and this way enzyme that helps in receiving, or in that helps in giving the place for the substrate molecules. By this, what happens is, by this what happens, this activation energy. Look at this graph. If we plot time on one side and particle energy on the other side, if we plot a graph, see here, these are the substrate molecules with higher energy. Without the enzymes participation, this I'm explaining. This substrate molecules without enzyme participation and with their higher energy levels, they starts the reaction and reaches a state which is called as transition site. And at this point, enzyme and the substrate molecules togetherly makes a complex which is called as enzyme substrate complex. And next, furtherly, this complex from transition site, they undergoes changes and gives the product plus enzyme as it is. That means structurally change, enzyme will not undergo any changes. Only substrate molecules, they changes into substrate molecules changes into end products or uh, final products. So here enzyme participates in the reaction but do not undergo any change. That's why yesterday in characteristic features of enzymes, we discussed one point. These enzymes are reused, they are recycled. Yes, by this graph, we can say that this enzymes, they takes part in this reaction along with the substrate molecules, and they forward the reaction with the with the increasing the rate of reaction, and finally they gives the end products and the enzyme that comes out as it is without undergoing any change. That's why here enzyme is enhancing the rate of reaction. Enzyme helps in increasing the rate of reaction by giving the place, by giving the support to the substrate molecules irrespective of their activation energy. So here, without energy participation, we can see this parabola very height, isn't it? That means this indicates the usage of activation energy is high in the absence of enzymes. In the absence of enzymes, activation energy is more, whereas this activation energy is decreased in the presence of enzyme. See here, lowering of activation energy by using a catalyst or enzyme. Enzymes works as a catalyst, isn't it? So here, this activation energy in the presence of catalyst or in the presence of enzyme decreased or decreases. So why it is decreasing? Because all the molecules, irrespective of their activation energy, irrespective of their energy, they participate in the reaction. That's why this activation energy lowers. So, how the what is our title? How the enzymes enhances the rate of reaction means molecules having different activation energies. Uh, Molecules with different activation energies shows interest in participating reactions by the enzymes influence. In what way means? By having the active sites on the enzymes, this molecules comes and takes a place on the enzymes, and as a result of this taking position on the enzymes, these molecules becomes very closer, and because of this closureness, bonds will be framed between these molecules. So finally, they makes a complex, and the complex that furtherly undergoes changes and giving end products. So this equation without the enzymes participation, and this one is graphically shown in this by having high amount of activation energy without enzyme reaction takes place, and with the enzyme participation, this reaction uses very less activation energy. Those two things are represented in this graph. So very in detail, if you observe this graph here, progress of reaction or time is plotted on one side, and potential energy of molecules is plotted on the other side of the graph. This here substrate molecules with their minimum energy, they participate with the without support of enzymes and with the support of enzymes. Without the support of enzymes, transition state is transition state. They reaches the transition state by using higher amount of activation energy without enzyme, and after reaching this transition state, they furtherly participates in the reaction changes, and finally they gives the product plus enzyme as it is. And here the next graph, this graph is by using less activation energy with enzyme. That means in the presence of enzyme, activation energy lowers, and they very easily reaches the transition state, and after this they furtherly changes into end products. So here this is the reason behind the enhancement of a rate of reaction. And here few points say molecules, if the enzyme is added to this reaction, enzyme provides site for all the substrate molecules with different activation energies, and molecules with more energy come and attach with the enzyme active sites, and molecules with the same energy also can make the bond with the enzyme. Even with the less energy, molecules also make the bond with enzyme. That means irrespective of their energies, irrespective of their energies, they comes and gets a contact with the enzymes at the active sites. And then next, this indicates that the enzymes has lowered the activation energy. That means number of molecules are increasing by the contact with the enzymes. So naturally this energy, what is that activation energy, that will be lowered. So in the presence of enzyme, by that maximum molecules with minimum energy also with minimum energy molecules also takes part in this reaction. So maximum molecules participates in the reaction and increases the rate of reaction. So finally, what we can say, this role of enzymes in a reaction is to lower the activation energy. To lower the activation energy, and enzymes are helpful and giving end products in a very short period, also in a large number. These enzymes are helpful. That we can understand by saying this graphs. The next is also with the same, and taking one side particle energy, and this is time.
PDF అయిపోయిందా?
అయిపోవాలి. ఇది ఫిఫ్త్ నాటిది నా యోగా క్లాస్. అందులో ఫిఫ్త్ సీనియర్ సెట్స్ ఫిఫ్త్. Yes.
Yeah. It is videos.
Okay, sorry for the interruption. Next, coming to the classification and the nomenclature of enzymes. Nomenclature means naming system of enzymes. So here there are two methods. One is old method and the other is recent method. So there are two methods, old and recent. First, we will discuss about the old methods. In old methods, there are three important types. One is putting suffix, ase, that is is, putting suffix is to the root word. That means, you know the meaning of root word, starting word, first word of the enzyme. For example, this will be explained by taking one example. Example, maltose enzyme is there, and this nature of maltose enzyme is that shows effect on one substrate maltose. Sorry, this very sorry. Taking example maltose as a substrate. This is a substrate. Maltose is the substrate. On this, one enzyme definitely that should be there to digest it, and that enzyme name that comes by adding is as a suffix. Then what is the root word? Root word is M-A-L-T, malt. Malt is the first word of this substrate. So this first word malt is treated as root word, and to this root word malt, this is suffix is added. By that it becomes as maltase. Malt is a root word, is a suffix. So in this way, first in olden methods, first method it was put into practice. So this enzyme indicates that it works on the substrate maltose. So this enzyme name is extracting by adding a suffix to the root word. By that it is showing the enzyme name maltose, maltase, and maltose is a substrate. So, and another example for this is sucrose. Sucrose is the substrate, and acting enzyme upon this is sucrase. By adding this is, by adding the suffix is, it becomes sucrase. So this sucrase enzyme that shows effect on the, or that helps in digesting the substrate sucrose. So in this way, this was the first old method. In this, putting suffix is to the root word will get the enzyme name. Then second, naming based on the source. That means source of the enzyme. That means, for example, this will be explained by taking one example. Naming is based on the source. So here, example is a bromelain enzyme. Bromelain enzyme. This for this, the source is family Bromeliaceae. Bromeliaceae family is a source for Bromeliaceae family. From Bromeliaceae family, we can extract this enzyme. That's why the source of this enzyme is Bromeliaceae family. And then next, another example is papain enzyme. Papain enzyme, for this papain enzyme source is papaya. You know the papaya fruit. That tree is a source for papaya, papain enzyme. So in this way, the second method was taken. The third is naming is by giving two words. That means each enzyme has two words. See, giving two words name to a enzyme. giving two words name. In that, the first, see here, giving two words name to a enzyme in which the first word indicates substrate and the second word indicates the type of reaction. So, in old methods, this is the third type of a naming system, in which each and every enzyme has two words. The first word that indicates the substrate name and the second word that indicates the reaction, type of reaction. For this, we'll observe an example, that is yes. Appointed? Okay. The older, in old methods of naming enzymes, in that the third method is naming is given by two words. Uh, in these two words, the first word indicates a substrate name and the second word that indicates the type of reaction. So here, this will be explained by taking one example, that is pyruvate decarboxylase enzyme. Pyruvate is a substrate and decarboxylation is a type of reaction. Here, decarboxylase indicates what means? D means removal. Removal of carboxylase, that means carbon dioxide. So here, what is a reaction taking place means removal of carbon dioxide is that change is taking place, and this change is indicated by one enzyme, that is decarboxylase, in which D means removing or removal, carboxylase means CO2, carbon dioxide. Removal of carbon dioxide is a reaction, and that reaction is handled by this enzyme, and this removal of carbon dioxide from which substrate? That is pyruvate substrate. So here in pyruvate decarboxylase, pyruvate is the substrate and decarboxylase is the type of reaction. So as per this naming system of old methods, each and every enzyme has given two words name, in which the first word indicates the substrate and the second word that indicates type of reaction. By this we can understand the old methods. So in old methods, That means in nomenclature of enzymes, there are two types of nomenclature systems are there. The first one is old type of naming systems. In old type of naming systems, there are three methods. The first one is giving or putting suffix ase, and this suffix is added to the root word, and by that we'll get the enzyme name, and that acts on the substrate. Example, maltose is the substrate and acting enzyme is maltase. By adding ASA to this root word MALT, we'll get the enzyme name. And the second method of naming system is this naming system based on source of material, and name will be given to that enzyme. So for that example is bromelain enzyme, and this bromelain for this source is Bromeliaceae family. From Bromeliaceae family members or in Bromeliaceae members, we can observe this enzyme. And same papain. Papain is enzyme, and this papain is extracted or it is observed in papaya family or papaya members. And the third type of naming system is giving two words name to each and every enzyme, in which the first word indicates the substrate and the second word indicates the type of reaction. And this is explained by one example, that is pyruvate decarboxylase enzyme, and in which pyruvate is the substrate, or pyruvate represents substrate, and decarboxylase is it represents the type of reaction. And in this, decarboxylation means removing carbon dioxide molecule. So by this, this method was implemented. And after this old methods, recent method of naming was implemented, and that will be explained in our next class. So these are the naming techniques, and how the enzymes enhance the rate of reaction. That means enzyme reaction, rate of reaction is enhanced by the participation or by the involvement of enzymes. Why means this enzymes they provides the place for the substrate molecules irrespective of their energy levels, and the maximum number of molecules participates in a reaction. That's why activation energy will be lowered, and end products, their number of molecules they increases enormously, or in a higher rate end products will be increased. So by that, the enzyme reaction rate of enzyme reaction will be enhanced. And classification and in nomenclature. In nomenclature, two types of systems are there. Old method of system is there, and recent methods are there. In old methods, three types are there. The first one is naming is given by suffix ase to the root word, and second is based on the source, naming will be given, and third method is by giving two words name, in which the first word indicates or represents the substrate and the second word represents the type of reaction. So tomorrow in our next class, we'll discuss about the recent method nomenclatures and other topics. Thank you.